moving on, we are now going to get into inequalities. Okay, so graphing inequalities on a number line and solving inequalities. Right, so what is an inequality? Right, an inequality is a relation between two expressions that are not equal. Okay, so we've been doing equations, right? Like equal, they're equal to each other. Now we're saying they're unequal to each other. So they are no longer equal, they're unequal. And that means they might be less than, they might be greater than. Sometimes you even see just not equal at all. You can also have less than or equal to. So that means it can either be less than or it can be equal to. Greater than or equal to. Okay, so these are like all the different signs in inequalities. Right, so we're starting to get into things like where they're, before we would do something like this, right? Equals 12. Now we have an inequality, it is unequal. This side is less than the other side. Okay, before we were solving for this, now we're solving for this. Okay, so let's just, before we get into like the actual inequalities, let's just do really basic ones, right? So if I wanted to graph x equals 6, right, I would just, it's just a point, right? X is 6, it can't be 5, it can't be 4, it can't be 7, it can't be any other number. This point here that I draw on 6 represents x, it represents my answer. X is 6. Oops. When we get into inequalities, we're now going to have multiple answers. Okay, so I'm saying x can be less than 6, right? So if you think about that, there's a lot more than just one right answer. When you have an equal sign, you're just saying x can be one number. When you have a less than or greater than sign, x can actually be like a ton of numbers now, right? It can be 5, 4, 3, 2, 1, 0, -1, -2, -3, right? So it just goes on and on and on, all the way to negative infinity. So the way I'm going to draw that is, first of all, actually I'm going to say less than or equal to first. First of all, I'm going to draw my point at 6, right? Because remember, x equals 6 means I put a point at 6. I have a less than or equal to, so it can be equal to 6 or it can be less than. And then what I would do is maybe just like shade in the line, and then I would shade in the arrow to represent that this can keep going and going forever. So all this, the shaded area represents all possible values for x. Right, so if I pick a number in the shaded area, so let's say I pick this number here, this number is 2. Is 2 less than 6? Yes, it is, right? If I pick a number here, I don't have grids, but you know, maybe that's like -3 or something. Is -3 less than 6? Yes, it is, right? So I can pick any number in this whole shaded area, and that will fulfill this inequality if I plug it in, right? -3 is less than 6, yes. 2 is less than 6, yes. I can plug in any number I pick as long as it's in shaded area. If I pick outside of the shaded area, right, let's say I pick 7, will that work? No, 7 is not less than 6. Okay. So now let's do, what happens if we don't have that equal? So we had x is equal to 6, x is less than or equal to 6. How about x is just less than 6? Right, so that means it cannot equal 6. It can only be less than 6. 6. So the way we do that is we have an open circle. Okay, so because I'm saying like 6 is kind of my reference point. right? X cannot be 6, but it has to be less than 6, so it's my reference point. I'm going to do an open circle to represent like starting from here, but it cannot be 6, and then anything less than it. Some students, I'll notice, will start at 5. That's not correct because we have to think about decimals, right? So technically 5.9999999 is less than 6, right? And it's not equal to 6. So that's why we need to have our reference point start at 6, and then we shade everything to the left, and I shade my arrow to represent that this keeps going for infinity. I just can't draw a line for infinity. Some people like to also graph it this way, where they'll do it above, like they start at 6 and they draw like an arrow instead of actually shading the line because it gets kind of messy. So, you know, maybe for this one they would do a closed circle and they draw it to the left. Whichever way you like. It's not going to matter though if you're doing it online. The online ones too are just like multiple choice. But, you know, if you're going to draw it in real life, I've seen it done both ways. You know, it's a little less messy doing it this way. So whatever you like is up to you. Okay, so let's just graph a few. Or let's go over the rules first, right? So if you have less than or greater than, just remember your circle is going to be open, right? Like right over here. Because it cannot be equal to the number, but the number is the reference point. If it has that less than or equal to, then you're going to have a closed circle, right? Like right up here. Okay, and then if you have less than, any kind of less than, you're going to shade to the left, right? Because you're getting smaller and smaller. So if you want to get smaller and smaller, you go to the left on the number line, right? If you have greater thans, you shade to the right because it's getting bigger and bigger, right? Numbers bigger than x. Okay, so let's just do a few examples. Oops. Really, I always just, when I do a number line, I just get my 0 as the reference. Like this is, you know, where the guide for which side is positive, which side is negative. And then I only graph the number that I need. But if you wanted, you could fill out the whole, you know, thing. But it doesn't really matter. You really just need your reference point. Okay, so we've got it's greater than or equal to. So what does that mean? That means it can be equal to -3. So I'm going to have a closed circle. Okay? X can be greater than -3. So greater means anything to the right. So that means I'm going to shade to the right. I'm also shade my arrow, make it darker. Or again, if you want to do it like this, that is fine too. And you can always test this, right? If you pick any number that falls in the shaded area and you plug it in for x, so let's say I pick this number 4, is 4 greater than or equal to -3? Yes, it is. Right, let's pick one on the wrong side, 3. -6, is -6 greater than or equal to -3? No, it is not. And that makes sense, it's not in the shaded area, right? Okay, so this time x is greater than 5. Is that going to be a closed or an open circle? It's going to be open, right? Because it cannot be equal to 5, it can only be greater than 5. So 5 is our reference point. Greater than means I shade to the right. Either way you want to do it. You might get something like this. This time we just have two parameters. So what I like to do first, I'm just gonna put my numbers that we have. And it's important to pay attention to what side the x is on compared to each number. Okay, so x is greater than, right, it's got the bigger side, or equal to -4. So I'm going to do this first reference point here, just this side. It's greater than or equal to, so that means I can have a closed circle, right, because it can be equal to -4. And it's greater than, right, the bigger side is towards the x. So that means I know I'm going to be shading this way, but I'm just getting started. And then I'm going to do the other side. X is less than 4. Open circle, right? Because it can't be equal to 4, just less than. Less than means I shade this way, and that means I can shade where they meet. Right, so because x is between -4 and 4. That's essentially what this is telling us. Right, so and we can test this. Like if I pick a number, let's pick -1, I'm gonna plug it in. Is -1 greater than -4? Yes, it is. Is -1 less than 4? Yes, it is. So it checks out. If I pick outside, let's say I pick -5. Oops. There. Is -5 greater than -4? No, it is not. But -5 is less than -4, right? So it checks out on one, but it doesn't check out on the other. It needs to check out on both sides in order to be true. So this shaded area between represents all the answers, all possible answers for x. Okay, and this goes for decimals too. Sorry, lost my, so that this includes all the decimals. So I could, 0.54 is technically on here somewhere over there, right? So even all the decimals. That's why we shade the whole line. We don't just draw dots on each number, because we're shading in between is representing all the little decimals and fractions in between each whole number, because they're all also right answers. All right, so that's just the basics of graphing number lines. Just as long as you remember these, hopefully that's helpful. So now we will move on to solving